who's not here. So we are now recording. Let's get the slideshow set up from the current slide. And, okay. Got this in the mailbox yesterday, and it says, urgent notice, action required, 2 exclamation points, all caps, bold, underline, and highlighted. So I think they're saying it's pretty important, okay? Attention Lawson State instructors, that's us, please announce in your class about the 2020 through 21 FAFSA and post in your area. So I'll be posting it after I made the announcement to all the classes. This is from Lawson State Community College Student Financial Services. And here's what the big announcement is. Important notice. Please note, Lawson State Community College will be converting to a new student information system for the 2020 through 21 academic year. It is imperative that you ensure that your 2020 through 21 FAFSA is complete and ready for processing. If you have not completed the 2020 through 21 FAFSA, please report to the Office of Student Financial Services on either campus for assistance. Also, please check your student email or student portal on a regular basis for updates. Now, here's what this means. I don't think there's very much changing with FAFSA. There may be some minor changes. They may be updating a few things, just normal stuff. The big change is what we're doing, okay? Way back when we were Bessemer State Technical College, we had one and then another program for entering students and grades and attendance and all the things that we normally do. Then when we merged with Lawson and became part of Lawson State Community College, when we combined with Lawson State Community College, the old package we had been using wasn't robust enough, I guess, to handle the bigger thing, so we went with the system they were using. And that system was an ancient system. My impression of it, it was a political boombox, because the chancellor we had at the time was more of a politician than he was an educator. And he was always running deals. And I think he ran this deal with buddies of his, somebody he had, and they provided this computer program that was really awkward, really ancient, really pathetic old program. And that's what he required everybody in the system to use. Well, everybody got used to it and knew it pretty well. They lived with its idiosyncrasies and quirks and cranks and things like this. But now we've got a new chancellor. Oh, by the way, that old chancellor, he went to jail. Okay, he worked so many deals, not with this, but with other things, and was caught enough times they finally convicted him. He may be out of jail now, but last I heard he was still in jail, which is good riddance. But now we've got a new chancellor, and we've had several since then. But this new chancellor is also a politician, and he wants his package in, and his package is a newer one, which should be better, and it's called the Banner program, okay? Now, from what I understand, it's awkward too. Really, really awkward. Very, very, very different from what we've done in the past, okay? So what this boils down to, now this is my interpretation. The new system, Banner, you can't just pull over stuff that you had from the old system, because they're totally, totally different systems. They don't communicate, they don't translate, they don't do anything well with each other. So, whereas your existing students, if you came next year, you would just update your FAFSA information. Probably in financial services, they could just do a few clicks and had you covered. I don't know, I'm guessing. Now they can, because next year they're going to this new system. Everything everything has to be entered new. All the students, all the student numbers, everything has to be done manually, pretty much, and it's going to be a mess. It is already a mess. We've had people down in Montgomery for weeks at a time for the last several months, and we'll continue to have people in Montgomery for weeks at a time over the next several months. And they're learning this new system, and it is a slow process. Okay? Corey's here. And Eddie, yeah, is here. Okay. All right. So, the point being, they don't want you waiting around till August to get your FAFSA updated, because it's no longer just a few clicks. They need the new FAFSA. It's just like you're a brand new student, okay? They've got to enter everything from scratch. So they're wanting all existing students to get their FAFSA done for next year so they can start the process of entering you all in the system, making sure it's entered correctly and that type of stuff, because come next fall, we're going to have a whole bunch of new students, and they're going to have to do the FAFSA for them, and they don't want any of your FAFSA information clogging up the system that they can't get the new students in, because everything has to be done from scratch. So the thing is, if you have not already, yes?
If we're going to be graduating this year, do we have to do that?
Okay, if you think you're going to need FAFSA, like you're coming back to take a couple courses or something like that, if you think you're going to need it next year, if you would normally be doing it, do it. If you aren't going to be doing it, if you're going to be transferring somewhere else, yeah, you don't have to worry with it. Okay. But only if you think you might be back next year for any reason whatsoever, and might be using your federal free application for federal student aid for next year, do it now. It's out there. You can do it now. Please do it now, because it will save them and save you a lot of hassle later on. Now, these are ones you won't hear some of these again, because they're coming up really soon. Tomorrow, Wednesday, February 12th, from 9:30 to 11:30, on the Birmingham West Campus, Lawson State's College Transfer Fair Day will be held in the Academic Building, which is B Hall, on the Birmingham West Campus. And that will be from 9:30 to 11:30. Then on Thursday, day after tomorrow, 2 days from today, it will be on this campus from 9:30 to 11:30 again. This campus, this building, Building A, and they say on here campus cafeteria. I kind of doubt that, because the cafeteria is not that big, and that will be the end of breakfast, the beginning of lunch, and I just don't think they can handle everything, not all these places, in that one cafeteria. I think what they mean is in the faculty staff dining room, which is right next door to the cafeteria, but hardly anyone uses. There they have plenty of space to set up tables. They may not get everybody in there. They may have a few in the cafeteria. They may have a few out in the hall. But they'll have them around that space, okay? So that's Thursday, February 13th, day after tomorrow, here on campus. Now, I had considerable interest. At least 2 students came by to get information about this. This is just one of many research experiences for undergraduates. These are programs that are sponsored by the National Science Foundation, trying to encourage students to get interested in STEM fields, that's science, technology, engineering, and math. This one I'm announcing now is primarily engineering, specifically mechanical, electrical, and material engineering. But there's others out there that hit other areas of engineering, other areas of science, other areas of mathematics, other areas of technology. So this is one that sounds extremely lucrative, okay? Most of these are 10-week internships. They come right in the middle of summer term, so it doesn't mess with your spring term. It doesn't mess with fall term. Now, it may mess with your summer term, but hey, what a deal this is, and how much you learn at these things. Not only do they not charge you a dime for it, they pay you to go to it. $5,000 stipend on this one. All of them aren't that lucrative, but this one is. You also, just about all of them, receive free housing, which usually includes a meal plan. So they feed you for 10 weeks, and they provide airfare there and back, one round trip ticket to get you there and get you home. If you want to come home on the weekends or something, that's on you, but they do that. The deadline for this is February. Now on the email it said February 15th in two places, but in the brochure it says February the 17th. 17th makes more sense. That's a Monday. 15th is a Saturday. That doesn't really make a lot of sense. But you can get more information about this, but this is this week, okay? This Friday or Saturday is the 15th. 1 week from yesterday is the 17th. So please, if you're interested, get the applications in soon. And most of the applications, like I said, there's many of these programs out there. Maybe not all applications will do this soon. Some of them may have already passed. Others may be in the future. Please get those. If you're interested, get working on that. I think I got everybody when they came in. 6 people here. Whoops, I didn't get everybody. Who did I miss? Brandon, you can know. All right, good deal. All right, any questions on anything I've talked about or anything in trig that we've done so far? All right. Well, we're in Chapter 4, Trigonometry. The measurement of triangles is what that stands for. We're in Section 4.5, Graphs of Sine and Cosine Functions. Okay? And what we started on last time was translations of sine and cosine curves. This is on page 301. And we're on the slide right in the middle of the page, Graphs of Sine and Cosine Function. Now, this is building on what we've already done. But this is giving not the whole picture, but most of the picture. The graphs of y is equal to a sine bx minus c. Now, I don't like the way they associate these, and I'll show you what I mean later, okay? And y is equal to a cosine bx minus c. Again, I don't like that too much. Have the following characteristics, and here we always assume that the b is positive. No assumption about a or c. Now, of course, you don't usually have a equals 0. That would just wipe out everything. So, a is non-zero, okay? C could be anything. Usually it's not 0 either, otherwise, well, it could be. So, how is the a related to anything on the graph? What's the a related to? Amplitude, exactly. The amplitude is indeed the absolute value of a. That's why we don't want the a to be 0, because it has no amplitude. You go in a straight line. Okay? So a may be positive or negative, but the absolute value of a is your amplitude. Okay? Now, what is b related to? No, b is sine and cosine. Now b is the period of the function, exactly. Okay? And how is it related? 2 pi, which is the normal period for sines and cosine, divided by b gives you the period for this function here. Okay. Now, what they like to do is say the left and right endpoints of the one cycle interval can be determined by solving the equations bx minus c is equal to 0, because that gives you the left-hand endpoint, and dx minus c is equal to 2 pi, that gives you the right-hand endpoint. Solve for x. And that works. That's perfectly fine. Here's what I like to do. It's just a little bit different, and it's because I I'm more used to physics than obviously the authors are. But I like to, let me get my pen set up. Okay. I like to take this bx minus c and actually factor out the b. So that would be b times x minus, and when you factor out, that's the same as dividing b over c. I'm sorry, c over b. Okay, sorry about that. Okay, and that's how I like to write it. Y is equal to a sine b times x minus c over b. Except I like to just call that the phase shift, c over b. I don't like to go through what they're doing here. Okay? So I just make this my C. You know, don't have an extra letter there, just make that C. That then is the phase shift, and this is your adjustment to the period, that's the adjustment to the amplitude. What they do is doing the same thing, but they have to do it twice down here. If you solve this, you do the same thing. This would be x equal that would be a c over b, which is exactly what we've got here, and then this would be 2 pi plus c over b. Well, 2 pi plus c divided by b. So it just makes a really awkward thing. You just do this and just make this your c. That's your phase shift. There's your deal with the amplitude. This is your phase shift. You don't have to fiddle around with dividing these things. But either way works. Just be sure you know which way you're doing it. And when you start doing the exercises, I hope it'll make more sense. Which leads us to the first. Whoa. Huh. They skipped example 4 and went straight to example 5. So let's back up. Oh, wait, there it is. All right, let's do example 4 here. Okay. Analyze the graph of y is equal to 1/2 times the sine of x minus pi thirds. Okay. Now, it says analyze the graph of, which basically means graph it. But I like to do the analysis first. What's the first thing you see in that equation? The 1/2. What does that stand for? And that is your amplitude. So the A is equal to 1/2, which implies the amplitude is 1/2. Absolute value of A, 1/2. Got it. What's the next thing you note here? The B is 1, okay? You don't see a B, you understand it to be a 1. So what does that influence? B influences the, someone said it earlier, period. And what's your period here? 2 pi. 2 pi over B, but B is 1, so that's just 2 pi. That's exactly what we want. Now, the next thing I do here, as soon as I get the period, anyone want to make a guess? Divide by 4. That gives you your interval. Once you know the period, divide it by 4. So 2 pi divided by 4 is pi over 2, and that's your interval. Okay, that's pretty important. Next thing, Now this is set up exactly the way I like to have it. What is your C here? Pi thirds, okay? That's how I like to do it. The thing that follows the x minus, that's your C. And what do we call that? The phase shift, okay? The phase shift. Also, you could call it the horizontal translation, okay? Okay? But we'll call it phase shift. And that is pi thirds. Now, in this problem, because your interval that you need to put the x-axis into is pi halves, but your phase shift is pi thirds, what you have to do in this one is get the least common denominator for both of those. What would that be? Pi 6, okay? So I'm going to do everything in terms of pi 6. Now this is how I do it. You don't have to do it this way, but this is how I do it. So here's our graph. This is a sine function. So I'm going to put my x's here, and we'll do 1, 2, 3, 4, 5, 6, 7, 8, negative 1, 2, 3, 4, 5, 6, positive 1, 2, 3, negative 1, 2, 3. Okay. I'll do one more. Okay. Now, the y is easy. If you let that be 1 and this be minus 1, yuck. Yuck. Okay, minus 1. Because your amplitude is 1/2, you're going from plus 1/2 to minus 1/2. Okay? You're not going to plus or minus 1. For sine and cosine, that's a real important thing to do. Okay, now remember I said the interval was pi halves, but the phase shift was pi thirds, so I need things in terms of pi 6. So unfortunately, that's what we're dealing with here. So this is pi 6, this will be pi thirds, this will be pi halves. Now if you don't follow that, 1 pi 6, 2 pi 6, 3 pi 6, okay? And what I'm going to do now, I'm going to do pi thirds and pi halves on here. There's a pi thirds. 2 more of these is 2/3 pi. And 3 of these is pi. Okay. And 2, 4, 6, that's pi. And then another 2 would be 5 pi. No. 7 pi 6, right? No, I didn't want that. Sorry. Count. 1, 2, 3, 4, 5, 6, 7, 8, 6 pi's, which is 4/3 pi. Okay. Going the other way is minus pi 6, minus pi thirds, 2 pi 6, minus pi halves, and minus pi. That's not right. Minus 2/3 pi. Count. 1, 2, 3, 4, 6 pi is minus 2/3 pi, and then this would be minus pi. 1, 2, 3, 4, 5, 6, 6 pi is minus pi. Okay. Now, this is a little more complicated than most because you have different denominators, but this is how I like to do it. Get it set up this way. Okay, now, always start with the phase shift. Okay? And what is it? Pi thirds. And that's to the right, so you're starting right here. Now, where does sine usually begin? At 0, okay? So this is where your new 0 is, Okay? Now, that's what the phase shift does for you. It gives you that. Now, your your interval is pi halves. So that's 3/6 pi, right? Pi halves is 3/6 pi, right? Pi halves is 3 pi over 6, right? So, I'm going to count from here 3/6 pi. Now, every one of these is pi 6. So 1, 2, 3, that's going up to your max, which is 1/2. 1, 2, 3, that's going back down to a 0 here. 1, 2, 3, that's going down to your minus pi 6, minus 1/2. 1, 2, 3, that goes back up to a 0, and then you'd be heading back up. So here's how it looks. There is your graph of this function. Okay? Things to note here. Phase shift is where we begin. Knowing it's a sine function, sine begins at 0, goes up from there down in the opposite direction. The interval, pi halves, because we're division into 6 here, that'd be 3/6 pi. So from here, 1, 2, 3, that's your max. 1, 2, 3, that's down to 0. 1, 2, 3, that's down to your min. 1, 2, 3, that's back to 0. 1, 2, 3, you'd be back to the max there. So once you get those points in place, go on. Okay? Does that make sense? Okay. You need really to go through most of these steps. And once you get that done, it works out pretty well. This was a little bizarre because your interval, which is pi halves, and your phase shift are different fractions. So we needed at least common denominator of pi 6. So everything was done in terms of pi 6. You start at 2 pi 6, and then the interval is 3 pi 6. So every 3 pi 6. You start at the phase shift. Okay. Now, they do it a slightly different way in the book, but it comes out the same. They start at pi thirds, and they show you going as far as 7 pi thirds. That would be your 2 pi. I didn't go that far, but you could have. If you squeeze things up together pretty well, you could have shown that. Okay. Now, again, every example has a checkpoint. Please try to do the checkpoint as soon as you can after class. Any questions on this? All right, let's go to example 5. All right, here's example 5. Sketch the graph of this one. Y is equal to -3 cosine 2 pi x plus 4 pi. Okay? They've made this a bit awkward, but it is doable. What's the first thing to note? Okay, A is equal to -3. What does that imply? What you were saying? The amplitude is 3. Perfect. All right. Now here's what I do, they don't do. Okay? I like to take what's in here, factor out the b. So I want to write this as y is equal to -3 cosine of, factor out the b, 2 pi, and that leaves me x plus 2. See that? If you factor the 2 pi out, that would be x, so 2 pi times x is 2 pi x, plus 2, because 2 pi times 2 is 4 pi. I like to do it this way. They do it a slightly different way, and it works out the same. I like to do that. Now, to me, everything is pretty obvious. We already did the amplitude. What's the next? The A was -3. What's the next letter in your alphabet? B is what? 2 pi. And what you do once you know the 2 pi? Divide it by or into 2 pi. So that means your period is 2 pi over b, which is 2 pi over 2 pi, which is 1. And then once you know the period, what do you do with that? Okay, that yields the interval is 1 over 4. Okay, so 1/4. Got that down. Okay, now, okay, next, you got your A, your B, what's next? C. Now, I'm doing C my way, not the book's way. My C is -2. Remember, it's always x minus C. Always is x minus C. So C is -2. Okay, now what does that mean? Say again? A phase shift, which way? Remember, anything dealing with the x is always backwards. It's to the right. So this will be phase shift is, no, wait. No, because this is what you're right, is to the left, okay? Yeah, because here, you see, it's opposite, so that would be to the left, okay? Is 2 units to the left, okay? Because of the minus, I'm sorry. I did that once there, okay? So phase shift is 2 to the left, okay? Now, your interval is 4, your phase shift 2, that's doable, okay? It's going to be a bit weird, but let's do it, okay? All right. I'm going to need quite a few ticks here, so I'm going to do them pretty close together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 1, 2, 3, 4, 5, 6, 7. Okay. Now, this is, remember, your y-axis. This is your x-axis, as usual. Okay. Now, your interval was 1/4. So each of these is going to be 1/4. This will be 1/4. This will be 1/2. This will be 1. 1, 2, 3, 2. 1, 2, 3, 3. This will be negative 1/4, negative 1/2, negative 1, 1, 2, 3, negative 2, 1, 2. Okay. Keeps on trucking. All right. Now, where do we start? Phase shift. And it's 2 to the left, or -2. There it is. So we're going to start right here. Now look at the function. Where does cosine normally begin? Okay, where on the y-axis? Normally? No. Sine starts at 0. Cosine starts at normally 1. Okay, but we have a magnitude of 3, the amplitude of 3, so it's going to start, and it's negative, it's going to start at -3. So let's do -1, -2, -3. 1, 2, 3. Okay. You feel all right? All right. Right now we're dismissing Amari and Austin at the top of the alphabet, and Ian and Angelica at the bottom of the alphabet. The middle of the alphabet, strong. Okay. Now, so we found that we start at the phase shift, -2, and go down -3. That's where we're beginning. Because normally the cosine starts at +1, but because we have the negative sign, it flips it down, and because it's 3, we start down there. Now remember, each of our tick marks here is a quarter, that's our interval. So it's going up from here to 0, up from here to plus 3, down to 0, down to minus 3, up to 0, up to plus 3, if I can find it, down to 0, down to minus 3, up to 0, up to plus 3, down to 0, down to minus 3, up to 0, up to plus 3, down to 0, down to minus 3, up to 0, up to plus 3, and down to 0. Going in the opposite direction, it started down here, so it goes up to 0, up to plus 3, and down to 0. So here's how this cosine function looks. I draw really lousy curves. Now, one thing to notice, never make the peaks pointed. Always have them rounded. Some of mine are too pointed, I understand that, but try to get them rounded. Okay. Now, the phase shift has the starting here. The first period would be from here to there. But the period is 1, remember? So sure enough, that would be 1. The next period would be to here, and the next one would be to there. But you see, this is exactly like this one. So because you were an even number of periods off, this is exactly the same graph that if you had not had the plus 2 pi, 4 pi at the end. You know, it works. Does that make sense? Okay. So do your analysis. Find your A, figure out what that means about your amplitude. Find your B, figure out what that means about your period. Once you know your period, divide by 4, that gives you your interval. Then I like to rewrite this in this form, and then whatever is here, that's your phase shift. That's your, the C is the opposite of that, and that is your phase shift. So the minus 2 does mean you're back this way. Because this is a plus here, and you shift this way. Okay? And so the phase shift is 2 whole units to the left. That's where you begin. Then take the cosine function, which is normally starting at 1. That would be here. But because you have a of -3, you multiply 1 by -3, and you get -3 down here. So this is where it's starting. And then every interval, you go back to your, this is a min, intercept, max, intercept, min, intercept, max, intercept, min, intercept, max, intercept. That's what your interval tells you. Every one of those you're doing, going to one of your key points. Intercepts, max, or min. You started with a min because of the -3, so every interval. That's why I put them down in intervals. Notice there's no pi's on that one because the pi's were taken out in your 2 pi over pi. 2 pi over 2 pi just became an interval, a period of 1. An interval of 1/4. So you just go from there. And if you look in the book, you'll see that one period goes from -2 to x equal -2 to x equal -1, just like we drew here. They drew several intervals, just like we did. Okay. Now they like to list the minimum, intercept, max, and all that kind of stuff. If you want to do it, do it. To me, it's just easier to do it right on the graph. All right. So I'm talking about what they did. Let me erase mine. Can I? Y'all got it? Or are you still writing? Okay, everybody got what they need? then let me erase all the ink from the slide. Is that okay? All right, and let's see how they proceed. The amplitude is 3. Now, I like to actually say A is equal to negative 3. That implies the amplitude of 3. B is equal to 2 pi. That implies the period of 2 pi divided by 2 pi, which is 1. And then I like to do the interval is that period divided by 4. They don't do it, okay? But to me, that makes it easier when you're graphing. Then they solve their equations. Now, if you factor out the B here and do it that way, you come up with the phase shift. They never call it a phase shift. They do this factorization first by that equation and get that, which x equals negative 2. If you had done the phase shift like I said, you'd have gotten right there. Then they do it the next time, and that makes it x equals minus 1. So they say, you see that the interval negative 2, negative 1 corresponds to one cycle of your graph. If you had done the interval, found the phase shift, started there, and then done them, you'd have gotten exactly the same thing without having to do so many calculations and interpretations and that kind of stuff. Just do it, okay? And dividing that into 4 equal parts. See, I divide first and then plot it. They go through all these calculations, then divide. We get the same thing, but I just did it on the graph, you know, and it's so, to me, so easy to do there, okay? And there's the graph, which looks maybe not as neat as mine, but close to it, okay? There's the graph exactly like we said, one period of that graph. But you could have started at the negative 3 there and done one period that way too. That would have been fine. The final type of transformation is a vertical transformation. Remember, we did A sine or cosine, bx minus c, so I like to redo that, plus d. Now, for some reason, they turn around and put the plus d in front. It's fine, okay, but that's your vertical translation. That is shifted d units up if d is positive, d units down if d is negative. In other words, the graph oscillates about the horizontal line y is equal to d instead of about the x-axis. So everything is just shifted up d or down d and then oscillates about that. Okay? They're skipping example 6, which needs to be done. So let's back up and do example 6. And we'll do it right here. Sketch the graph of y is equal to, and here they put the d in front again, 2 plus 3 cosine 2x. Okay? Where would you begin? Second? Amplitude? Okay. I like to start with the letter A. A is equal to what? Second? A little louder. Someone say 3? Yeah. A is equal to 3, which implies the amplitude is 3, right? What's the next one? Second? B is equal to? Okay, wait. What is B? 2. P is 2. And what does that imply? The period is 2 pi over 2 over your B, which is pi. Now that you got the period, what does that imply? What do you do with that period? And what's your interval? Is equal to pi over 4. Take the period, divide it into 4 equal pieces. Pi fourths. Okay? Next. C. Y'all see a C? No, it's 0. C is 0, there is no phase shift. Okay? And finally, D is 2. This 2, I wish they'd have used a different number, but that's your D. That's your vertical shift. Okay? So, I think we got everything we need to set up our graph. Okay. Okay. Now, where do we normally start? The phase shift. The phase shift is 0. So we're starting on the x-axis at 0. But your D here is 2. So let's go up to that point right there. Now, when you find that point, what I like to do is put in a dotted line there. Okay? Because that's our new equilibrium point. Whatever your phase shift is, ours has to be 0 and then go up to whatever your D is. And that was up to. That's our new equilibrium. That's where we're going to put everything. So, I'm going to mimic my tick marks here. Okay. What function, now that we've found where our starting point is, what function are we dealing with? Cosine. Where does cosine usually begin? Second? Okay, at 1, at your max. But what's your max now? 3. 3 above this vertical shift. So that's going to be 1, 2, 3. That's where we're starting. And then every tick mark is going to be one of your intervals. Okay? So this goes down to 0, and then down 3 from this tick mark. 1, 2, 3. So that's your next one. Okay? Then up to the next tick, and up to your +5 here, and then down to your next tick, down to your -1 here, up to your next tick there, up to your next max here, and then down to here. Okay? Going backward, down to your that, 3 below that, back up to 0, back up to 3, down to 0, and down to -1, up to 0, wherever it would be, up to -1, okay, or +5, okay. So here is your graph now. Now, things don't quite look balanced here because my spacing up above and the spacing down below aren't quite the same, but it's pretty close. Everything's symmetric about, not quite symmetric, but is about your new baseline, equilibrium line, which is at your CD, which is 0, 2. And everything is measured from there. All right? Do you see how that goes? And just remember, cosine usually starts at your max, unless, of course, your amplitude was negative, then it'll start at the min, okay? But whatever your amplitude is, that's where the cosine usually begins. +3. And then it's going to go for its min 3 below the baseline, which is 1, 2, 3. So that would be down here, -1. So it's going from +5 to -1. which is, by the way, the difference between -1, +5 to -1 is 6, which is exactly twice your amplitude. Amplitude up, amplitude down. So amplitude 3, that's exactly twice it. You see how you handle the vertical translations. All right. All right, to move on. Anyone still writing? No, there are some still writing. So. See, for me, getting the intervals in place, that sort of removes the need for having to do your this equals to 0, this equals 2 pi, and then dividing by 4. Just get the interval at the very beginning, and you've done all that then. And remember, you go from wherever you start, it's either up or down, a max, an intercept, a min, max, you just do that every other step, every interval. Okay, anyone need this a little longer? You got it? Okay. So let's go to example 7, or mathematical modeling. Okay. The table here shows the depth in feet of the water at the end of a dock at various times during the morning. So this is going from 12 o'clock midnight to 12 o'clock morning. Okay? Where T equals 0 corresponds to different. Okay? So this will be 2 a.m., 4 a.m., 6 a.m., 8 a.m., 10 a.m., and 12 noon. All right. Now here's the depth of the water. Okay? It starts at 3.4, then it goes to 8.7, then to 11.3, down to 9.1, down to 3.8, down to 0.1, and then up to 1.2. Okay. Now, where they usually begin this, here's where I would begin. Okay? Notice you've reached the max. It took you a while to get to it. And then you dropped to a min, and it started going back up again. So here's your minimum. There's your max. Okay? Now, if you think about, if this is sinusoidal, okay, following a sine curve, that's going to be the max. This is the min. Now, what parameter? What are our 4 parameters? A, B, C, D. What parameter deals most closely with max and min? A, because that deals with the amplitude. But remember, the amplitude is half the distance between the max and min. It's the distance above the equilibrium position and below the equilibrium position. So if you take the difference between these, which I can do in my head, that's 11.2, divide it by 2, and you get 5.6. So halfway between those two, that's your equilibrium position, 5.6. And what do we call that? D. So the first thing you can do is difference here gives you twice the amplitude. So the difference here is 11.2. Half of that will give you 5.6. That is your amplitude. Okay? Right. Okay? And what's the next thing I just said? And this is also your Okay. And that's also your, is that your D? Yeah. Not quite. Okay. I think I may have said that wrong. That's your amplitude is half of that. So you got your A now. Well, plus or minus A. We don't know which. Okay. Now, that's related to A. Let's see. Related to the A. Okay. Now, what is all right. This is max. That's the first thing we noted, and this is min. Okay. Now, what is between, okay, now what we have been doing is xy. Now it's ty. So what we have been calling x is now t. Now, if the max is here and the min is here, how many intervals are in between the max and the min? You have one equilibrium point in between, right? There's two interval points, right? Okay. So, between here and there.
Well, you say if the max is up here, the min is down here, you saying the interval point?
Yeah, there's two intervals between that because it has to come back to equilibrium and then go down the min, right?
Okay. Oh, you're saying.
Yeah. So I'm going now to the x or the t here. Now your interval is going to be on the t-axis, so that would be half of the difference between these two. The difference between those two is? The difference between 4 and 10? 6. And half of that is 3. So your equilibrium point, or your interval is going to be at 3 hours, okay? Because these are hours, okay? So your interval is going to be 3 hours. So your interval is 3 hours, okay? Now that we know the interval, what do we do? Now, you realize we're sort of doing backwards from what we did before. How did we get the interval before? Say again? The period divided by 4. So if we got the interval, you can multiply by 4 and get the period, right? So interval times 4 equal period, right? So that would be, period would be 12 hours. So this is one period right there, okay? Now, in reality, we're not quite on the nose here, but we're getting close enough, okay? So your period is that. Now, what do we also know about the period? The period, what's the formula for it? 2 pi over b, okay? Well, the period is 12 hours is equal to 2 pi over b. So multiply both sides by b, okay? And divide by 12. So b is equal to pi over 6. There's your b, right? So we got your A, we got your B. All right. Now, we need your C. Now, what the C depends on is whether you're going to count this a sine or a cosine function, right? Which would you be tempted to count it? We've got the interval of 3 hours, okay? And that would make it at 7 o'clock in the morning is 1, okay? And 3 from this would be 1 o'clock in the morning would be another. So this is either, it's up to you. The sine usually goes like this, cosine goes like this, okay? If you're doing cosine, then your phase shift is going to be 4, right? Because you're starting at that, cosine starts at the max. If you're doing sine, you usually start at the equilibrium point, which would be 3 from this, which would be here. So either your phase shift for sine is going to be 1 hour, or phase shift for cosine is going to be 4 hours. Which do you want to do? Second? You want to do cosine? Of course you would, wouldn't you? Okay. That's what the book does. Okay. So just for my purpose, just to show you can get the same answers, I want to do sine, just because I like to be different. Because this is starting. Okay. If you had plotted this, which they do in the book, in fact, I'll just show you. There it is. Okay. Now, this is midnight, 1, 2, 3, 4, 5, and 6. No, this is every 2 hours. Why did they do that? Oh yeah, I guess that's what it is. Midnight, 2, 4, 6, 8, 10, and 12. Yeah. Okay. That's how they did it. Okay. Now, the equilibrium position is exactly halfway between these two. So it'd be, another way to say it is the average of those two. So it's going to be right around, we figured it out, that was 7 o'clock, wasn't it? Right there is the equilibrium position, right here. And to me, see, this is, sine would be starting here and going up. So you, like I said, that's a 1 hour phase shift here, whereas cosine would be starting here and moving like that. So that's a 4 hour shift there. So I just assume goes with 1. 4 will work. The book did it that way, so you can certainly do that. So since I'm going to use sine, I'm going to put my, for using or modeling with the sine function, that produces C is equal to 1. 1 hour phase shift here. Okay? Now, the D, that is what I just said. These are max and min. You subtracted those and divided by 2 to get your amplitude. To get your D, you take the average of these two. That would be 11.4. Add those two together and divide that by 2, and that gives you 5.7. That's going to be your D. This is your A, there's your D. They're awfully close to each other, but they're not related necessarily. Okay? And then, so now you've got all 4 letters that you need. Okay? So now, since I chose to do sine function, I would do it this way. Y, which is the depth, is equal to, I like to start with A. A is 5.6 times the sine of, now I like to take the B and pull it on the outside, and that would be pi 6 times x minus C, which is x minus 1. Now, I like to do the D at the end, plus 5.7. There's my equation, okay? Now, we hadn't even gotten to the question yet. It said, the table shows the depth in feet, blah, 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 blah. Use a trigonometric function to model the data. There's my trig function. I'm going to use to model the data. where X is in hours, T is in hours. I'm sorry. I've been harping on it all this time and I put X in there. Okay. T is in hours and Y is in feet. Okay. Okay. So there's my model. If you had done the cosine, then the amplitude is still the same. Cosine would be fine. But now your B still would be pi 6. Okay, that's still pi 6, but it would be T minus 4 because that would be going to here, and your 5.7 would be the same. So everything would be the same except you would do T minus 4 there, cosine of T minus 4, I do sine of T minus 1. So otherwise, they're just the same. Now, what the book does is put in decimal numbers, which sort of mess things up a little bit. We're okay. So there's my trig function. Brandon's would be y is equal to 5.6 cosine pi 6. Now, I'm doing it my way. T minus 4 plus 5.7. Okay. Now, that's the A part. Okay. Now, I just want to point out to you, our B was pi 6. Their B is 0.562. I mean 524. Someone do 5.6 on your calculator. Pi 6. Pi divided by 6. And what do you get? Pi divided by 6. That's 0.524, isn't it? Rounded off. Okay. I just assume use pi 6. It's easier to write, and, it's going to give me a little more precision. Okay. So the B part, find the depths at 9 a.m. and 3 p.m. Well, 9 a.m. would be right in here. So use our formula. You can use either one you want to. I'm going to do y is equal to 5.6 sine of pi 6 times 9 minus 1 would be 8. If you're using Brandon's, you use 9 minus 4 would be 5. But cosine, okay, plus 5.7. Okay, now you do this in the middle first. So I'm going to make this a little easier, 4/3 pi. So 5.6 times the sine of 4/3 pi. Now I can do 4/3 pi in my head almost. Isn't that root 3 over 2? I believe it is. Plus 5.7. Punch it in your calculator, see what you get. Yeah.
What's that number in parentheses above?
Above the 8?
Yeah.
Okay, yeah, that's a 4. 4/3, yeah, 4/3. 4 in the numerator, 3 in the denominator. I divided 8 and 6 by 2. That gave me 4/3. And 4/3 pi, I think, is root 3 over 2. So anyway, punch it in and see what you get. What's the depth at 9 in the morning? Anyone get it? Say again? I'm sorry? I can't hear you. How much? Okay. Okay. What I'm saying is, 5.6 times either sine of 4/3 pi, and then add 5.7 to it, or y is equal to 5.6 times cosine of, and that would be 5/6 pi. No, 5/6 pi plus 5.7. Whichever you do, what you get as an answer. Y is equal to
I got 5.7.
5.7. We've hit that before, haven't we? That doesn't seem right, because it should be between 3.8 and 0.1. Okay? So either I've done something wrong or you've done something wrong. So I don't have a calculator on me. Someone punch in these numbers. 5.6 times square root of 3 divided by 2 plus 5.7. Yeah, do it this way. 2.8 times square root of 3. Wait, that's not giving us right, is it? I'm doing something wrong. What's that? Okay, there's something going on wrong here, and I haven't quite figured out what it is yet. Okay. Starting here up to max. Oh, that's right. Okay. I should have said negative. Okay. That's it. Because sine of 4/3 pi, I was doing second quadrant, it's third quadrant. It's negative. Okay. And it should have come out negative for you too. It's 2.8 times negative root 3 plus 5.7. 2.8 times negative root 3 plus 5.7. Punch those in and see what you get. 0.85. That sounds more like it. That's in between these two, and that seems reasonable. Okay? Now, I don't know why what you did sort of messed up there, but when you did 4/3 pi, sine of 4/3 pi, that should have given you a negative number. That negative number times 5.6, and then add to 5.7. You sure shouldn't have gotten 5.7, because this was negative and you're subtracting from 5.7. So, anyway, I think we got, let's see what they got. They got 0.84 feet. What did you say? 0.85 feet. Yeah. Theirs is round off error. Okay. Now the second question is, how about 3 o'clock in the afternoon? That's outside of our range here, isn't it? But you can still do it. What is your t then? If t goes from 0 to 12 here, what would it be at 3 in the afternoon? $12 plus 3 is 15. So you would plug 15 in here. Okay? So y is equal to 5.6. Now I'm using sine. If you're using cosine, it'll be, and this will be pi 6 times 15 plus 5.7. Okay? Well, 3 will go into 6 twice, and 3 will go into 15 5 times. So this is 5 halves. Well, sine of pi half, 5 halves pi, I'm pretty sure that's 0, isn't it? Right? So that would be 5.7. And at 5 o'clock, we should be right at our equilibrium position, which would be 5.7. So that's what I got. Whoa! I must have done something wrong here. Oh, wait, I'm sorry. I did do something wrong. It's not 15, it's 15 minus 1. So this should be 14. No wonder I was off. Okay. Okay. Sorry, that's 14. Because it's t minus 1. 3 o'clock would be t equal 15. Minus 1 is 14. So now we can do this again. 2 will go into this 3 times. 2 will go into this 7. So that's 7/3 pi. All right, let's go back and think through this. Where are you when you're 7/3 pi? Well, 6/3 pi would be at 2 pi. 7/3 pi, you're in your first quadrant. So this is root 3 over 2. So same as before, but this time it's positive. 2.8 times root 3. This time is a positive root 3, and then plus 5.7. So do that one for me. 5.6 times root 3 plus 5.7. What you get? 2.8 times root 3 plus 5.7. Say again? 27. Whoa. Root 3 is what? It's 1.7 or so, isn't it? Root 3. Multiply that by 2.8. 2.8 times that is going to be something less than 5, I think, isn't it? Okay, then add 5.7 to that. Say again? 10.03. Now that's better, but it's not what they get in the book. Huh? 10.46? That's closer to what they get in the book. They get 10.56. We got 10.46. And again, it's their round-off errors because they rounded. See, they're giving you 4 digits here, but they only rounded their B to 3 digits. So you can't give that many digits precision. So yeah, I'll buy 10.46. Okay? Because, I'm sorry, I messed that up before. I was using 15, not 14. And 3 o'clock in the afternoon should be very close to this. And sure enough, between 8.7 and 11.3, 10.46 is right in there. Yes?
What's underneath the fraction?
What's that? This fraction here? Okay, it was 5.6 sine of pi 6. That's what we had here. T minus 1. 15 minus 1 is 14 plus 5.7. Okay? Well, then I divided 2 into 6 would be 3, and 2 into 14 would be 7. So 7/3 pi. 7/3 pi is 1/3 pi more than 6/3 pi, right? 6/3 pi would be all the way around, and another 1/3 pi and the sine of 135 pi thirds is root 3 over 2. So that's why I said the root 3 here divided 2 into that, and that's what I got from 2.8. This made for a little bit easier calculations. Since I didn't have a calculator, I was trying to make it easier for y'all. Okay, now, the next one they say, using a graphing utility.
It's time.
Is it time? Okay. I'll just say this. The C part you need a graphing utility to get. You can look at it in the book and see how to do it. If you don't have one, don't sweat it. Anyway, you see what they get. We'll go over that next time. We'll begin at the C next time. Okay. We'll start with C next time. Okay. You'll have to remind me what our formula is, and we'll go from there. We almost finished the section. So homework exercises, any of the odds 5 through 11, they're all at Calc Chat. 7's at Calc View. Any of the odds 13 to 19, they're all at Calc Chat. 21 or 23, they're both at Calc Chat. 25 through 29, they're all at Calc Chat. 27's at Calc View. 37 to 51, they're all at Calc Chat. 49's at Calc View. 53 to 57, all at Calc Chat. 55's at Calc View. 59 to 63, they're all at Calc Chat. 65 or 67, they're both at Calc Chat. 65's at Calc View. 69 or 71, they're both at Calc Chat. 71's at Calc View. And then 73, that should be at Calc Chat. And 75 through, or 77, both at Calc Chat. 75's at Calc View. You can do, I think, 79. Any of the odds 79 through 85. They should all be at Calc Chat. 87 and 89 should be at Calc Chat. Those are true false. There's a conjecture at 91 should be at Calc Chat. There's a writing one if you want to do that. 93 should be at Calc Chat. And 95, if you want to try that, you can do that at Calc Chat. We'll pick up and finish this and do the vocabulary and then move on to 4.6. Finally. Okay. Good deal. Any questions? All right, we'll see you Thursday.